You will now understand how to identify the terminals of a compound DC motor. Open the cover of the terminal box carefully, taking care not to damage the gasket. Remove the interconnections between the terminals. You come to know that there will be 6 terminals in a DC compound motor. 2 terminals are for armature winding. 2 more terminals are for shunt field winding. 2 more terminals are for series field winding. Assume that the terminal indications are faded or not available. You have to identify them now. Give arbitrary numbers against the terminals indicated as shown. Confirm that the brushes are in their respective positions on holders. You knew that there will be no continuity between the 2 terminals of the armature winding and the 2 terminals of the shunt field winding. You knew that there will be no continuity between the 2 terminals of the armature winding and the 2 terminals of the series field winding. You knew that there will be no continuity between the 2 terminals of the series field winding and the 2 terminals of the shunt field winding. Using the multimeter in the resistance range, check the continuity between the terminal 1 and other terminals 2, 3, 4, 5 and 6. Assume that there is continuity between the 2 terminals 1 and 4. Certainly they should form one of the 3 windings. Check the continuity between the terminal 2 and other unidentified terminals 3, 5 and 6. Assume that there is continuity between the terminal 2 and terminal 5. Certainly, these 2 terminals should form one of the remaining 2 unidentified windings. Certainly, the remaining terminals 3 and 6 should form the remaining unidentified winding. You have now identified the 3 windings individually without identifying which one is what. You check and confirm that there is no continuity between the terminal 1, 2 and 3. This confirms that the 3 windings are electrically separate. You have to then identify as to which the armature winding is, which the shunt field winding is, and which the series field winding is. You knew from theory the following. The armature winding and series field have always less resistance value than the resistance value of the shunt field winding. This is because the armature and series field windings have to deliver large current output than the shunt field input in the DC motors. Measure the resistance of the individual windings using a multimeter. Assume the following. The resistance value between terminals 1 and 4 gives 0.2 ohm. The resistance value between terminals 2 and 5 gives 2 ohms. The resistance value between the terminals 3 and 6 gives 0.1 ohm. You can say that the terminals 2 and 5 belong to shunt field winding since its resistance is high comparing with others. You check the continuity between the commutator segments and terminals 1 and 3. Assume that you get continuity between the brushes or commutator segments and terminal 1. Then you can decide that terminals 1 and 4 form the armature winding. Logically, the other winding with terminals 3 and 6 is the series field winding. Mark the terminals with correct terminology with paint. Mark as A1 and A2 for armature, S1 and S2 for shunt field, and F1 and F2 for series field winding. If you have the catalog of the motor with you, you can also compare the values of these resistances with the values given in the catalog. Conclusion: you have successfully identified the terminals of a DC compound motor.